So next, let's look at the current in electrochemical cells. Now we have to differentiate between the entity current and voltage. So in electroanalytical methods, as in galvanic cells, it's the voltage that we are very much interested in. And so in order to harness more voltage, it is important that the amount of current that flows through that particular external circuit must be reduced as much as possible. And the relationship that exists between current and voltage is given by this equation right here. So voltage is current times the resistance. The resistance of any circuit is given in terms of the unit ohms, and current is usually given in terms of amps, and of course voltage for the E is like that. So in order to harness as much voltage as possible from your voltaic cells, it is therefore imperative that the resistance be increased a lot. And in quantitative chemical analysis, we also saw that the more you increase the resistance of the potentiometer, this is the symbol of the resistance there, the more you increase the resistance of the potentiometer, the more that potentiometer acts to show or to read off the voltage as high as possible, as possibly you can actually obtain from that. What I'm saying here is that the potentiometers are designed such that they are high resistance gadgets, and in them having high resistance, therefore they are able to first of all measure the voltages that will be given off by these systems. And also, since it's the voltage which is the ultimate objective of us having the galvanic cells in the first part, they are able to channel and direct that where it's needed. So therefore, that's the relationship that we need to actually look out for here. So there are other factors that can have an influence on the quality of the potential we get from a cell such as this one. And it says here, this is actually important, it says that the measured cell potential normally departs from the derived thermodynamic calculation. So this derived thermodynamic calculation is what we would get from things like the free energy, and of course the equilibrium constant K. So essentially what that is, these are thermodynamic calculations. You can kind of go ahead and calculate and find out theoretically how much you can harness in way of voltage using the principles that we've just discussed here. But it is always found that there is a significant deviation, at times even a very significant deviation from what you get practically when compared to what you calculate in your calculation. The thermodynamic theoretical values are actually sometimes significantly different. Now, what do we attribute those particular differences to? There are a number of factors here. Things like polarization effects. Remember, we are dealing with charged particles here, charged ions. So the issue of polarization becomes a very important one. And there is a whole section on polarization in your textbook. And I would like you to go ahead and just read through that section. This is, if you're using the edition, which is the Skog Holler, the current edition. This is the, which edition is this one? The 6th edition. In the 6th edition, go ahead and see page 648. Refer to page 648, section 22E. That whole section is on polarization. I'd like you to kind of just treat this as a reading assignment. So polarization, I would like you to go ahead and read through ideal versus ideal polarization and non-polarized this is actually not working. Polarized electrodes. So you get the idea, because my pen is not writing at this corner. So is the ideal polarization, or ideal polarized and non-polarized electrodes and cells. Just refer to that section to read on that. Then we have also phenomena known as overvoltages. So we have reaction overvoltage, and this is the material that is actually on that next page, page 649. So again, just read through that overvoltage material. There's a very good reference paragraph there which talks about the overvoltage, and the equation is given to here as this E minus EQ, where we are talking about the value of the overvoltage, which is actually this symbol, which is equal to the actual electrode potential, and this is the equilibrium potential right here. So this is the actual potential, and this is the equilibrium potential. So that difference is the overvoltage. And again, if you just read through that, that would be awesome. And then the other factors like crystallization, overvoltage, that's another type, when we have this crystalline material being formed in the process of that electrolytic process. But again, this is more of a qualitative reason for us to get a deviation from the expected potentials versus the ones that are actually obtained experimentally. That actually brings, quite, in some cases it can become quite significant. But again, all calculation have to have this one taken into consideration, so that we know for sure that we are not going to get the maximum output from any of these electrolytic systems. Okay, so the next thing that we are going to talk about briefly here is the ohmic potential or ohmic drop, and this is actually the resistance that I'll be talking about here. So the current and resistance of the device that you are actually using to measure the potential. So this is your cell. So basically this is the cell potential that you get from a galvanic cell, for instance. Now the IR here is the potential, because this is also potential, but the potential here shown by IR is that potential that an electron that is flowing through an external circuit has to overcome before those particular electrons can flow freely from the cathode to the anode. So this resistance to flow of ions as they move towards the anode and the cathode, that particular value reduces or diminishes somehow the potential that you can harness from these particular cells. So basically that's what we refer to as the ohmic drop, and again, that's a factor which we have to take into consideration because it reduces the overall potential that is actually harnessed in any of these particular galvanic cells. So there we go with ohmic potential. Then we have charge transfer polarizations, and these ones are, with respect to the over voltages that I mentioned earlier. So again, this is a section that I would like you to kind of just refer to on page 649. Charge transfer polarization. Actually, this is actually page 649 all the way to 651. Those are 2 pages, and there's a very good diagram, figure 22.6. Is that 22.6? 22.8, that shows a schematic of the polarization effect on the electrode surface, and how that is actually transferred to the bulk of the solution. Now, it is not the intention of this course to go through all those particular subsections that they have actually done the derivations of these particular potentials there, or from the cell, but just an overview, a good understanding of the general principles that are applied when we actually harnessing these voltages. That's what we are going to be looking out for. Now, one final thing, there's number 3 and 4 here is voltages for electrical conduction here, and some over voltages for gaseous products and hydrogen. Again, you can just read through this, and again, these ones are also listed. The charge transfer over voltages here are actually given in itemized form. These 5 are also listed in your table, in your textbook on page 651. So just be aware of the 5 characteristics that cause these particular over voltages in the charge transfer polarization effects that are associated with them. So basically, that's the outline of the chapter right there. We will have some calculations coming up, but this being an introduction, we are really mostly going to be concerned only with the potentials that come from calculating the cell potentials in that way we have just kind of gone through here in this particular chapter. I will have, of course, the end of chapter problems are going to be 1A, B, 2, 7A, B, 8, 9, and 16. I have chosen those ones because they are representative of the type of questions that I would like us to lay emphasis on. Many of the other questions that are at the end of this chapter, especially like 18, require extensive, and 19 also require extensive use of Excel spreadsheets, which I would like to kind of stay away from those ones now, because you're not going to have that capability when you're doing an exam or something like that. But the principles, the main principles, especially when it comes to questions like number 7, I think this is the typical type of questions you should expect in this kind of situation. So practice on those, see how they are done, and if you have any questions on those, let me know, and then we'll talk about them. So that's it for now. I will talk to you later regarding other materials also, or this particular one if we choose to revisit it. Okay, that's it. Bye bye.